Welcome to part 2 of my series on home security video surveillance. Before we jump into all the technical information, let's answer the most common question I hear. How difficult is it to install a video surveillance? I'll answer this question by showing the basic installation of the different types of video securities. I'll start with the most common and the cheapest, hardwired standard analog. A large majority of the kits you'll buy on the market today consist of this system. We start out with a camera or cameras. All cameras require power, so if there's an outlet next to the camera you can plug it straight in. But it's more traditional to provide power from the same location as your DVR is located. To do this, you route a cable from the camera to the DVR. This is called a Siamese cable. There's actually two wires within this cable. One is used to route power. The other is a coax that hooks up to your DVR. Your video signal will travel along this coax. The function of your DVR, or digital video recorder, is to record the video from each of the cameras. It will also perform other functions such as allow playback and detect motion, send emails to you when it detects motion, and other things like that. It's the brains of the whole operation. And of course you have to plug the DVR in. This VGA output can drive a television or a computer monitor, or you can opt to use the HDMI output. Connect the Ethernet port to your router. This will allow you to watch your video on your home network, or send the video over the internet so you can watch it on your smartphone. Finally, hook up a mouse so you can control the DVR. That's all there is to it. Let me share a little tidbit with you that caught me by surprise when I hooked up my first video system. Keeping in mind everything has to be plugged in, including your modem and your monitor, and each additional camera. Well, we're already up to 4 electrical outlets. That there alone is more than your average house has in one location. And if you're like me and hook up 16 cameras, you can see you're going to have to do some planning ahead. As an option to the power strip, you can install an independent power supply to drive all your cameras. This will be the subject of a different video. Okay, let's get a little more expensive. The standard hardwired digital system. All of this equipment is going to be the same as on your analog system. The first major difference is you're going to replace your DVR, or digital video recorder, with an NVR, or network video recorder. This is because the cameras are going to send their images in digital format, so the NVR does not have to do any conversion, it just saves what it receives. The coax cable will be replaced with a Cat5 or Cat6 cable. This is the same cable you use on your home network. And finally, you're going to have digital cameras instead of analog. As a quick side note, all cameras actually capture images in a digital format. Just analog cameras convert it to an analog signal to send it down the coax. Then the DVR converts it back to digital again to save it. Now if you look at the Ethernet ports on the back of your NVR, you'll notice they're labeled PoE or LAN. PoE means power over Ethernet, and the NVR will actually provide power to drive the camera. You do, however, have to check and make sure the CAT cable you're using is rated to handle that kind of power transfer. The other ports are labeled LAN, or Local Area Network. These ports function exactly the same way as your network ports on your computer do. They transmit and receive data only. No power goes through them. So you'll have to find an alternate way to power your cameras. You can use a power over Ethernet adapter and plug it directly into an outlet. Then use a Cat5 or 6 cable to provide the power to the camera. Or if you have multiple cameras, you can get a power supply and feed that into a power over Ethernet switch. Then plug each of your cameras into that switch. Now you can connect the switch to your NVR. So it seems pretty obvious. To make your life simple, make sure your NVR you purchase only has power over Ethernet connectors. Since digital video is IP based, there's a very wide range of configurations you can use when you're hooking it up. For example, you can completely dump your NVR and send a signal to a local PC. Or you can send it directly to a router or modem and have it sent off-site. You may have noticed that I've mentioned a couple times that this is the same type of wire that you have in your household local area network or your home network. And I'm sure the thought crossed your mind, why can't I just use the existing wires that are in my house? Well, the answer is you actually can. You can hook up the cameras directly to that wiring, as well as your NVR. And because the video is IP based, the IP addresses will control all your signal routing. Seems too good to be true? Let me break out my red font. If you do this with multiple cameras, it will probably cause bandwidth problems. So unless you're a professional network administrator, I wouldn't even give it a try. Let me explain what a bandwidth problem is. The definition of a bandwidth is the amount of data that can be transferred across a data line in 1 second. For example, if you want to watch a 1080p video, you'll need to be able to process 1200 kilobits per second of data. English version of that is 1.2 million bits of information every second. Okay, let's let this box represent how much data your home network is capable of transferring. And let's assume your normal use of your network uses half of the data transfer possible. Add 1 or 2 cameras, probably won't experience much problem. Add 2 more cameras, you can see you're really loading down that data bus. You'll probably notice your network is going much slower now. Try to add a 5th camera and you could crash the system. The network just can't handle that much data. Okay, let's move on to wireless. As a quick disclaimer, I want to let you know I really don't like wireless systems. The 2 primary reasons are the range never seems to meet the advertised values and the lack of encryption on the video signal. I installed a wireless backup camera in my truck. Now when I drive by my local Subway sandwich shop, the video feed from their security system shows up on my backup camera. I can see who's in the shop and the cash register and everything else that you don't want a crook to see. But regardless of that, I'll try my best to present both sides of the wireless video system. We'll cover 2 different models. Wi-Fi, which works with your existing Wi-Fi networks, and your standalone wireless, which works independently from your home Wi-Fi network. On the Wi-Fi, some of the advantages are it's a digital video stream, so some encryption is actually possible. But make sure to check your camera specifications. If they don't say they use encryption, then you're most likely transmitting a signal anybody can see. It can easily be hooked up to your existing Wi-Fi network in limited numbers. Remember our talk about bandwidth. Video, audio, and motion detection can be sent to your smartphone. This would be great if you want to know when somebody's standing at your front door. And some cameras even have a built-in floodlight, which is much better than night vision. Disadvantages? This is usually a pay subscription video service. The camera sends video to your router and then out to a website. You pay for a certain amount of storage on that website, then the website retransmits it to your phone. And oftentimes your phone is the only way you can view the video. And even though they say they're wireless, you still need to plug the camera in to get it power. The wireless they're referring to is the video stream. If you do find a camera that's battery operated, the battery will need to be changed or recharged every couple of months, and that camera would more than likely only transmit video for 10 seconds after it detects motion. Make sure the camera you purchase matches your Wi-Fi frequency, 2.4 or 5 gigahertz. And the generation of your phone, for example 4G or 5G, must be capable of receiving that particular camera's video stream. And finally, your camera should be located within 30 to 50 feet of the router. Video requires a strong Wi-Fi signal. So you can see you got to do a little homework before you buy a Wi-Fi camera. Let's draw a picture of what we just talked about. Mount your Wi-Fi camera, sign on to the internet, and open an account with the camera's service provider. Now the video will be sent out to your Wi-Fi router. The router sends it over the internet. Then the service provider sends it to your smartphone. If the service provider allows you to log into your account with a computer, you can have the video sent back down to your router, then to your home computer for viewing. Oh yeah, don't forget to plug in your wireless camera. Let's move on to standalone wireless. Mount your camera and plug it in. The video signal will be transmitted off the camera's antenna over to your recording device, which also has antennas. Then the video will be routed via cable to either a monitor or your router. It is pretty simple. If 1 camera is not enough, feel free to add 3 more. You're probably asking yourself, why can I only have 4 cameras? Well, the reason is the wireless video signals actually interfere with each other. And the frequency that you're using is going to determine how many cameras you can use. The most common recorder runs at 2.4 gigahertz. There is a 5.8 gigahertz system, and I've read you can have up to 8 cameras. And they advertise considerably longer distance of transmission. I also found evidence of 2 other recorders at 1.2 gigahertz and 900 megahertz. But pretty much everyone on the internet says they're being phased out, so I didn't bother looking into them. Let's say you want to increase your wireless transmission range. You can install a transmitter power amplifier or purchase a specialized antenna. These have cool names like high gain directional or Yagi. Now that we've talked about how to stretch out your distance, what kind of things interfere with your radio waves? There's reflections, diffraction, scattering, and refraction, and finally attenuation. There's not much you can do about the top row of problems, but let me tell you about attenuation. Attenuation occurs when the radio wave passes through a material. The material absorbs some of the radio wave and weakens the signal. Plaster and wood will cause a 10 to 30% reduction. Brick, 30 to 50%. Concrete and cinder block, 50 to 70%. And metal cladding, 70 to 90%. And here's the real kicker. Wet or moist materials will cause a significant reduction depending on how much moisture and how dense it is. This includes the trees between your camera and your receiver. The quality of your video is directly related to the strength of your video signal. Full signal strength will produce a high frame rate. Likewise, a low signal will produce a low frame rate. I'll explain frame rates in another video, but for now it's good enough to know that high rate equals smooth video and a low rate is a jumpy video. Using this chart, you can now estimate how well a wireless video will work when you put it in your house. For example, if you're transmitting through a brick outer wall and a wood inner wall, you can probably expect a 40 to 70% signal degradation. Moving on, let's take a look at another type of wireless application. Let's say you want to keep an eye on the livestock in your metal barn. We already know from previous discussion, you can't transmit a wireless signal through the metal. To fix this, install a normal hardwired camera, then route the video coax up to a transmitter mounted on the outside of the barn. The video signal will then be transmitted to a paired receiver. The receiver will then place the video back on a cable. Then you can send it over to your recorder. Hang in there, we're almost done. Finally, I'd like to talk about the hybrid recorder. This unit actually has both analog and digital inputs. Here's why you might want something like this. Let's say you currently own an analog hardwired system and you want to upgrade to the higher resolution digital, but you don't want to throw all your old equipment away. Since I haven't discussed resolution yet, let me give you a quick rundown. One 5 megapixel camera can record as much video detail as about 6 analog cameras. Here's what I mean. This little square labeled SIF shows what you can see with a standard analog camera. And this square shows you what you can see with a 5 megapixel camera. But don't forget, your recording device also has to be capable of recording 5 megapixels. So now you can throw your old DVR away, hook the analog cameras to the hybrid recorder, buy digital cameras, then hook them to the hybrid recorder. And do you still have livestock in that metal barn? You can install that paired transmitter receiver we just talked about and receive the video wirelessly. And here's another reason why you might want a hybrid. Sometimes you don't care about the quality of the video. Like I use video cameras to monitor my gates to the backyard. That way I know if they're open or not. Or place a camera on your koi pond. Then you can use the recorder's motion detection to determine if critters are bothering your fish. For these applications, buy the cheapest analog camera you can get. Then install the expensive digital cameras when you actually care about video surveillance. Let's wrap this up. When might wireless not be right for you? If you need more than 4 cameras, you don't have power sources located where you want to mount your cameras, or you're living in a densely populated area. There just may be too many devices competing for your wireless frequencies. Examples are Wi-Fi, cordless phones, game controllers, and even microwave ovens. Well, I think that's enough for this video. On my next video, I'll try to cover some hardwired video system considerations for design and installation.